So we continue from where we stopped. So let's balance this atomically now. Let's balance it atomically. So atomically, we check the numbers of atoms of the species, the component of the species, that is the elements that are involved in each species. Here we have manganese. Manganese is one atom here. Manganese is one atom here. But oxygen is how many atoms here? 4 atoms. But oxygen is not here. Oxygen is not here. So there, and the species that we normally use to balance up oxygen is water molecules. Water molecules, don't forget. And we are being told that the reaction must be in what? In acidic medium. And when we talk about acidic medium, from the definition of acid, according to Arnold's concept, that acid is a substance that produces what? Hydrogen ions or hydrogenum ions when dissolved in water or solution. That is the meaning of an acid, which means in the presence of acidic medium, there must be a production of hydrogen ions. There must be a production of hydrogen ions. So which means we're going to have Mn, that is MnO4 minus plus 5 moles of electron. Can you see now? Then plus hydrogen ion to give manganese 2 ion, then plus water molecule. So we are going to have water here. So the water molecule we have where we balance up both hydrogen ions and oxygen atom. It will balance up both hydrogen atoms and oxygen atoms. So here we have 4 atoms of oxygen here and we have 1 atom of oxygen here. So but to balance it up, we are going to add 4, as the coefficient of water molecules at the right hand side. We are going to have 4 as the coefficient of water molecules. So which means we are going to have a total numbers of 8 moles of hydrogen. Now 2 times 4 is what? 8. So which means we are going to have a total number of 8 moles here, making up the hydrogen to balance up hydrogen, and that's 8 moles. So we are balanced this what? We are balanced it up atomically. We are balanced it up atomically. Don't forget that redox reaction is a stepwise reaction. You don't just rush it. It's not like an inorganic reactions or the one that involves acid and base, maybe normal acid and base without balancing on the ions. No, it's not like that. It doesn't work in that way. So don't forget that the first step is what? Locate the species that are involved in oxidation and reduction. And I told you the meaning of oxidation and reduction in terms of increment and decrement in oxidation numbers. Do you get it now? So then after that, you balance it up electronically, that is ionically, by comparing the number of electrons. Then atomically, that is by checking the number of atoms in each species. So that is the